This is the last topic in Unit 1, Section 1. It's converting degrees to radians and radians to degrees. And this is something that you will do a lot. And some of you will find that you don't think it's very hard, especially if you've had chemistry and you've done dimensional analysis. So I want to kind of go back to my circle. I had a circle here, and I was talking about degrees. This could be 0, 90, 180, 270, 360. Also in terms of radians, we know that this is pi. So this is half of pi. So that's 1/2 pi, 2/2 pi, so this is 3/2 pi. And this would be 4/2 pi, which is just 2 pi. So 1 pi, 2 pi. I'll make that a little clearer. That's 2 pi. So there are some conversions that we can use. And I typically just use the same one over and over. It's kind of like if I knew something was 6 inches and I wanted to know how many yards that was. I would have to use the conversion that there are 36 inches in 1 yard. So what we're using here is we're trying to find some kind of unit that we can use to compare to. And we know this unit right here. We know that pi radians is the same thing as 180 degrees. So I'm going to use that to convert. And let's just go through and let's do some conversions together. Let's say I want to convert from 30 degrees and find out how many radians. So I want to go from degrees to radians. If you did this in chemistry, you know you can set up an H-bar. And if you have degrees on top that you're trying to get rid of, you want to have degrees on bottom. So that means I want to have radians on top. So here I'm going to use my conversion of pi radians is 180 degrees. So then I'm ready to cancel out my degrees, and I have 30 pi radians divided by 180. So when you reduce this, you actually get pi over 6 radians. So pi over 6 radians is the same thing as 30 degrees. If I thought about that on my circle, 30 degrees would be somewhere right in here, and pi over 6 being right here would make sense, because 6 pi over 6 would be way over here, 3 pi over 6 would be here, so 1 pi over 6 makes sense to be right here in quadrant 1. Let's do another one. Let's try 135 degrees. If I want to change from degrees to radians, I'm going to take it times or do an H-bar where I have degrees on bottom because that's what I'm trying to get rid of, and radians on top because that's what I want to keep. So the degree and the degree will cancel, and my unit of measure that's left will be radians. And when I multiply that out, I have 135 pi, oops, no degree anymore, over 180. And then we can reduce that. Let's see here, 5 goes into 135 27 times. And 5 goes in here, I believe, what, 3... 6 times, and that reduces again. 9 goes in here 3 times, and 9 goes in here 4 times. So 130 degrees is the same thing as 3 pi over 4. I'm going to see if that makes sense if I draw out a picture. 135 degrees would be right here. Would it make sense that this could be 3 pi over 4? It does, because this could be 4 pi over 4, and that would be 2 pi over 4, so 3 pi over 4 would be somewhere in between. Okay, let's go do one that is a radian to start with. Let's think about 9 pi over 2 radians. So this time I'm trying to get rid of radians, so I want radians to be on bottom. And I want degrees to be on top. So this time the 180 goes here and the pi goes here. So when I multiply this out, and I'm not going to multiply it out fully, I'm just going to say 9 pi times 180 over 2 times pi. The pi's will cancel. 2 goes into 180 90 times, and 9 times 90 would be 810 degrees. Let's see if that makes sense. I had 9 pi over 2 radians. This would be 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2. So yeah, it makes sense that that could be 810 degrees. Let's do one more. Let's do negative, actually let's do 2 more. Let's do negative pi over 2. So I want to go from radians, 2 degrees, so I'm going to multiply it by radians on bottom, degrees on top. So pi on bottom, 180 on top. So now the radian on top and radian on bottom cancel. Anytime you have something in the numerator and denominator the same, they cancel. The pi's would cancel. So I'm left with negative 180 degrees over 2, and that simplifies to 90. So it would be negative 90 degrees. And that makes sense. Negative pi over 2 would just go backwards to this spot right here, and that makes sense. That would be negative 90. Now, what if they told you 2 radians, but there's no pi in there? Let's think about where that would be on the circle. 2 radians. So there's no pi, so I can't really use the fact that this is pi, but I do know that pi is the same thing as 3.14 radians. So this would be about half of that, 1.7 something. So 2 radians is going to be right in here somewhere. So I want to try to convert that. Since it's radians, I know I'm going to multiply. You can do h bar or just multiply. Radians on bottom. And I know that there are 3.14 radians and 180 degrees. And probably instead of 3.14, I'm going to use a pi right here so I can be exact. So on my calculator, I'm going to have 2 times 180, which is 360, and divide by the pi key. And my answer is about 114.59 degrees. I'm not going to be too particular when you round, but if you are doing an assignment in Delta Math, you'll just want to make sure and look at their directions.